So this video is going to show you how to solve combined gas law problems. I've got my equation up here where we have pressure, volume, and temperature all changing. So this combines the three Boyle's, Charles, and Guy-Lussac law from the last video. And with these ones, you're going to have a lot of numbers in the problem. All three are going to change. You know 5 of the numbers. We're solving for the 6th. So notice in my two problems that we're doing together, I wrote out all the variables. That's another way to keep track of all of your numbers. Hardest part of these is identifying the numbers for the problem and which equation to use. Once we plug it in, we just do some algebra and solve for whichever one we're missing. So with these, like the previous gas law equations, with temperature, we want Kelvin, not Celsius. But any other unit, they just have to match one side to the other. It doesn't matter which units we're working in. So let's look at our first problem. We have 4.24 liters. That'll be our volume at STP. STP is going to tell us both temperature and pressure. And then under 900 millimeters of mercury of pressure, that's going to become the internal pressure of the football. And then this is our second temperature. So filling in the numbers that we know, so we have millimeters of mercury as our second one. So I can fill that in. So we got 900 mmHg, which means that our first pressure at STP has to be that as well, which is 760. Volume, we know before is 4.24 liters. We don't see a liters or milliliters for the second set of conditions, so that's the one we're trying to find. We don't know V2. Temperature one is at STP, which would be 273 Kelvin. And then temperature 2 is negative 12 degrees. And remember, when we have Celsius, we have to add 273, so that would be 261 Kelvin. Okay, so we know all the pressure, volume, and temperature before. We know pressure and temperature after, but we don't know volume, so we're going to be solving this for V2. So we'll plug all these numbers into the equation, and we will solve for V2. So we've got 760 mmHg as V1 times, that's P1, sorry, times 4.24 liters over 273 Kelvin equals 900 times V2, that's the one we don't know, over 261 Kelvin. And the way most people prefer to do these is to solve, like plug this part, the left side of the equation, into your calculator, plug the right side in, and then reduce from there. So if you type in 760 times 4.24 divided by 273, that will give you 11.8. So this 11.8 is the left side of the equation. And then 900 divided by 261 gives you 3.45, and that gets multiplied by V2. And then we wanted to find V2, so we're going to divide by 3.45 on both sides. And because all our units matched, our V2 is just going to match the units for V1, which was in liters, so this one will be in liters as well. 11.8 divided by 3.45. Checking our sig figs. Technically this one is only 1, but we're going to pretend that that's 3. So we could keep 3 sig figs, but I only have 2 in my answer, so we're going to go with that. Oh no, I have 3. 3.42 liters. Here, I'll add a dot there. Make that 3 sig figs. So then all of our numbers were 3 sig figs, and our answer can be as well. All right, so solving for pressure and volume will be like that. I have a second one where we're going to solve for temperature, so we can solve for the denominator. Let's do that one. Okay, so we have a balloon that was 0.53 liters at 1 atmosphere and 298 Kelvin. So these are all at the same time. So the 0.53, that's our volume. The 1 atmosphere is our pressure. And 298 Kelvin is our temperature. And then on the other set of conditions, we've got 0.92 atmospheres as P2 and 0.38 liters as the volume. And we don't know the temperature, so that's the one we're trying to find. We'll plug in our numbers. So we have 1 atmosphere pressure times 0.53 liters, our volume, divided by 298 Kelvin. And then this one we have 0.92 atmospheres times 0.38 liters over temperature, 2. Okay, so this one, again, we can reduce it down, although I didn't solve it that way. So I'm going to have to plug this in my calculator real quick. So 0.53 divided by 298. All right, we got 0.00178 equals 0.3496 over T2. Now remember, with these T2s on the bottom, we can't just divide by 0.3496 on each side. That won't get us T2. That'll get us 1 over T2, the inverse. So first we want to do times T2 on both sides. And then we will divide by this number. So that's going to be T2 equals 0.3496 divided by 0.00178. And my answer might come out a little different than yours, but I got 196. Check these numbers here. Yeah, 196 Kelvin. So that can be our answer. We don't need to switch it to Celsius. But if you were curious, the temperature 196 Kelvin would be negative 76 degrees Celsius. All right, so all the combined gas law problems are going to have 5 numbers given in the problem. That's how you know to use that equation. You're given the 5 numbers, you're finding one variable. All right, that's it for combined gas law.